Hey, happy 4th of July. Today there's a project using parametric equations to model fireworks that I thought students would get a kick out of. This is geared particularly for students taking Precalculus, and it could be a culminating project for parametric equations. This is what our animation is going to look like when we're done. So the question then becomes, how do we go about building an animation like that? In this case, there are 3 or 4 prerequisite pieces of information that the student should feel comfortable with. For starters, quadratics and the parametric form of a quadratic. If we were to start and we had a term like x1, we could set it equal to a parameter t, and we had another term y1 is going to be equal to t squared, for example. We can then plot x1 and y1, and we can create a parametric. It can be hard to create a parametric equation the way you'd like it to using t in this context, so I'm going to add a slider, and I'm going to use a hack that I like where I just type in another term to get my slider for t, then I just get rid of my term. And now what I can do is I can animate that point x1, y1 using my parameter t, and we can see that it's moving like a projectile. Now, in this case, the students might be familiar with the idea of transformations, in which case, if I wanted it to look like a projectile that was being fired up, I would just flip my projectile here, and we can see now that it looks like it's going up and it's going down. So that is a parametric view of a projectile using a quadratic, and it's not hard to do. The next concept that students would want to be comfortable with, is a parametric circle. So parametric circles are similar to parametric parabolas in as much as we're defining in terms of another third variable t. So in this case, I'm going to treat the terms a and b. And when I combine them, we can get a circle. We're not getting our whole circle here. So if we wanted to get our whole circle, again, we want to create some type of a slider. I'm going to rename that slider t. And now I can animate that point around. Alternatively, if what I really wanted to do is make a bigger circle, I could do that as well by creating another term like c, in which case now we can see it looks like the point's moving in a circle. It looks like it's moving in a straight line away, but it's the same point on the same circle. In other words, I can rotate it, but now it's extending outward because the circle that it's on is getting bigger and bigger and bigger. And so those are 2 of the underlying skills that students would need to know, but there is a third skill that they need to know. And the third skill is, I think, really cool, and it takes a little bit of getting used to, but it's using a list in Desmos. So in this case, our list is 1, 2, and 3. Then the question might be, well, how would students use a list in this context? So if we had a graph like y equals x, and then I added the list to it, I would now get 3 separate lists. And this is going to be helpful. You're probably piecing this together for putting together our fireworks. Excuse me. You can do all kinds of things with the list. I can multiply it by 2. I can add the list to the number 2, and each element will be increased by 2. I can square my list. There's loads of things you can do with a list. A list is really just a way of storing multiple numbers so that you can use it to do interesting things. So going back to our project, we want to build a firework animation using parametric equations for a projectile, and then for the explosion. The explosion is going to look like a circle. So one way to get started with this is to go ahead and make the parametric part. So I'm going to use the exact same things that I previously modeled. And I'm going to flip this to make it look like a projectile. And I'm going to give it an initial height. I'm going to shift it up so that the projectile has some positive value. And then I'm going to plot that out. Remove these. I'm going to add a slider. And I know this is a weird hack. This is how I've gotten used to doing it. And so here we go. There's our point, and we can see that we're animating it along our trajectory. And there's lots of opportunities for creativity for students working on this project. One of the things that I think is going to be important in this case is we're going to limit the domain where this point is visualized using this term, and it's going to be to the points where t is less than 0. So as t approaches 0, it kind of disappears, it becomes undefined because its domain is restricted. So that's the first part. So we've created our projectile motion. Now the next part is to create some particles. So I'm going to use a list to do that. Now, in the last example where I was introducing the idea of a list, I just used the numbers 1, 2, and 3. In this case, we want to orient points around the circle. So I'm going to pick angles of 0, pi over 2, pi, and then 3 pi over 2. And students could pick more points or they could use fewer points, but this is basically going to create 4 points around the circle. So the next step is to go ahead and position those points. So what I'm doing here now is you can see the values in those lists, and I'm plotting out those 4 points. There we go. So there are our 4 points. And if we run through our animation here, we can see our projectile point goes up. And here are our 4 points. Our 4 points, however, aren't connected to where we would like them to be. So the next step is to adjust them. So we know that the peak of our parabola is at 5. So I'm going to go ahead and adjust the y coordinate over here to 5, and that shifts our points up. So as we animate now, our points show up where we want them, but they're there all the time, which we don't want. So I'm going to restrict the domain again. And in this case, it's going to be for t greater than 0. So it's undefined for values like -9, because those points aren't going to exist until we get to 0, and there are our points. But the points don't change at all. And what we want them to do is to expand outward. So one way we could do that is we could multiply them by t. And this is effectively mapping them to a larger circle. So each point is going to expand outward. And we can see there that that's what that looks like. And that looks pretty good. I like that. And the next step is to add a little more realism if we wanted it to look like a firework. So we would want it to fall. And it doesn't really affect the x parameter at all, but it affects the y parameter. So I'm going to go ahead and model that with minus t squared. And this comes straight out of physics. So if we were to go and look at projectile motion, we can see that the y coordinate, if we scroll down here, the y coordinate goes down by a term of minus 1/2 g times t squared. I'm just going to, 1/2 and g are just a constant, so it could be anything. And in our case, I'm just going to leave it as 1, which is to keep it simple. So now if we go back and test it, and I have my minus t squared term, we're going to see that the points fall. And it actually looks quite a lot like a firework, I think. So from beginning to end, this is what our firework display would look like right now. And that was pretty fast, and that might be too fast to really enjoy, so we could scroll it back a little bit and make it go a little slower and run it again from the beginning. So that's just a quick example of how to use parametric equations with quadratics and with circles, integrating in lists, and then putting it all together in an animation that should be really compelling for students and help them think about careers in graphic design, computer animation, and I hope you enjoyed this.